Hello everyone, welcome to the ITLS Academy. Today we are going to discuss another topic, that is your pH meter calibration. So what is this pH meter calibration are? Okay, first of all, this pH meter is used to measure the pH of the food products, chemicals and buffer. Okay, this pH meter is a electronic device. We can measure the pH with the help of the electrode. Electrode is present and this electrode is used to measure the pH of the products. So electrode is what? This electrode is used to measure the pH of the product. Now, this calibration is very important. If the pH meter is not calibrated, then it give a error, or you can say that the wrong result. So that's why this calibration is very important. So we have to discuss it how we calibrate the pH meter. pH meter is an instrument which is used to measure the hydrogen ion concentration of a solution. Basically, pH meter is nothing. It is a instrument. Instrument, or you can say that the bio instruments, that instrument that we use in a biotechnology laboratory, molecular laboratory, any laboratory. Okay. And basically, this pH meter is used to measure the concentration of the hydrogen ion present into the solution. Calibration is only ensured that the accuracy and reliability of the measurement, means that if the pH meter is calibrated, then it ensures that the result that we get by measuring the pH with that pH meter is accurate and error is not occur. Proper calibration is essential for the scientific way, industrial way, and food quality application. Okay, in all way, this proper calibration is very important. If the pH meter is not calibrated, then we does not get the perfect result. Even the we cannot get the result great or similar result. Okay, that's why this calibration is very important. Importance of the calibration. Compensate for electrode drift and aging. The first one is that it is the compensate for that electrode drift and aging, and along with it, it also ensure the accurate and reproducible reading, means that the reading that we get from the calibrated pH meter will be accurate and reproducible, means that we can use it in a future. Maintain instrument performance over time. This calibration also maintain the instrument performance required for quality assurance and regulatory compliance. It can be required for the both of that, for the quality assurance, and along with it, it also fulfill the regulatory compliance. Now, come to the next slide. Principle of pH measurement. Okay, so this pH measurement is based upon the electrochemical potential difference between two electrodes. Okay, so basically it based on the electrochemical potential of difference between that two electrode. We have a glass electrode and reference electrode. This uh, so this pH measurement is based upon these difference between these two electrode and their electrochemical potential. This glass store electrode is used to measure the hydrogen ion activity, and reference electrode provides the stable potential. The pH meter convert this potential into the pH value by using the Nernst equation. Now, calibration standards. Calibration, for the calibration of the pH meter, we required a buffer solution, but the pH of that buffer solution will be known. Okay, so here we can use our three type of the common buffer solution. pH 4 is for the acidic, pH 7 is for the neutral, and pH 9.20 or 10 is for the alkaline. And the buffer that we prepared for the calibration, they should be fresh, uncontaminated, and at the same time temperature as the sample. Okay, means that the sample of the buffer should be same as a sorry, the temperature of the buffer should be same to the temperature of the sample, and it should not be contaminated. Okay, if it is contaminated, then it will give a error. Types of the calibration. So we can calibrate it by using the three type. The first one is your 1 point calibration, it for approximate measurement. Okay, when we do a 1 point calibration, then it will not give a accurate result, but it give a approximate measurement. Next is your 2 point calibration, it improve the accuracy. And we can use here we can use three type of the two type of the buffer, that is your pH 7, or either we use pH 4 or pH 10. pH 7 is for the neutral and pH 4 is for either acidic or basic. This 3 point calibration is the most accurate type of the calibration because it give a high precision laboratory work. Calibration procedure. Okay, so first of all, what we have to do, we have to turn on the pH meter and allow it to the stabilize. Then we take a electrode and we rinse that electrode with the help of the distilled water and blow dry. Okay, then we immerse that electrode in first buffer, that is your pH 7, adjust to match the buffer value, and rinse with the water, then again repeat it with the pH 4 or pH 10, then we get the stable reading. So this is a procedure. Now we are going to see the procedure by a diagram way. So I'm going to draw a pH meter. This is your pH meter. This is a digital point. This is your knobs, three knobs, four knobs, 1, 2, 3, 4. Okay, so the first knob is for the temperature. Then second knob is known as a call knob. Then third is slope, and the fourth is function. Then here electrode is attached, and this electrode is always dipped with that KCl solution. This is your KCl solution. Now, the first thing is that why this electrode is dipped in a KCl solution, because if we don't dip that electrode into the KCl solution, then our electrode will be deteriorate. So, to protect the electrode, we dip it into the KCl solution to protect the electrode. Now, first of all, we have to prepare the buffer solution. Here we prepare the two type of the buffer solution. The first one is your pH 4 and the second one is for the pH 7. Okay, so first of all, what we have to do, we have a capsule. We take one capsule and dissolve into the 50 ml of the distilled water. Same with that pH 4. But both are prepared by a separate way. Now what we have to do, we take that capsule and twist that capsule and take the inert material, and then it will dip into the 50 ml of, it will be dissolved into the 50 ml of the distilled water. Then when it is completely dissolved, add remaining 50 ml of the distilled water. Now in your bottle, in from which you have to prepare that buffer, the temperature are written. So you have to set that temperature here. In my bottle, it is written 25 degrees Celsius. So we set it. Then we remove that electrode which is written in a in a previous slide. We take that electrode, wash with distilled water, wash with distilled water, then dip, then dry, then dip into the pH 7. Then we move this call button till here the sorry, um, not move that call button. Just a minute. After dipping it into the pH 7, you have to move the function key from the standby to the pH. Here some values are showing. Now what you have to do, you have to move the call button in a clockwise direction until here the pH reaches the 7. Move the call knob in a clockwise direction until you reaches that 7. Then stop it. Again move this knob from the standby, pH to standby, and again wash with the distilled water, then dry, then measure pH 4. Again move from standby to the pH. Here some values are showing. Now what you have to do, you have to move this slope in a clockwise direction. Move the slope in a clockwise direction until you get pH 4. Now your pH meter is calibrated and it is used for the measurement of the pH of the product. So this is how you calibrate it. And the video related to this are already uploaded in our account. You can see that for the better understanding. Now come to the next. Temperature consideration. So pH readings is vary with the temperatures. That's why the temperature is very important. Should the temperature compensated meters or measure at constant temperature. Buffers and samples must be at the same temperature. Means that if you are measuring the hot sample, then you have to heat the buffer because the temperature of that buffer and the sample should be at the same temperature. Electrode maintenance is very important. Store electrode in pH 4 buffer or electrode storage solution, that is your KCl solution. Never store the electrode in a dry. Okay, if you store the electrode in a dry, then it will be damaged. Avoid the contamination of buffer bottles. Regularly clean the electrode bulb with mild detergent or special clean solutions. Common error and troubleshooting like drifting reading, electrode aging or dirty bulb, slow response, dry or contaminated electrode, inaccurate calibration like old buffer or poor rinsing technique, unstable reading like temperature fluctuation or damaged cable. Frequency calibration daily for routine laboratory use. Okay, you have to calibrate your pH meter in a daily way, or when you started your work, you have to calibrate it before each critical measurement, after long storage or electrode replacement. Follow the manufacturer recommendations. Conclusion: regularly calibration ensure that accurate pH measurement, use fresh buffer, proper technique, and maintain electrode. Calibration is a key component of good laboratory practices. So this is all about the calibration of the pH meter. I hope you will understand, but if you have any query related to this, you are freely to ask me in a comment box, or for a further detail, you can follow the ITLS Academy on different platforms, that is Instagram, Facebook, Twitter, YouTube, WhatsApp, and LinkedIn, and subscribe our channel ITLS Academy on YouTube and get our app from a Google Play. You can also ask your query to the helpline number that are already mentioned in your slide, that is 7080833450, and visit our website, that is www.itlsacademy.com. Thank you for watching. Please like, share, and subscribe our channel.